Not only is it important for you to know these formula by memory, yes, you might say, but they are on the formula sheet. Sometimes they will give you the formula sheet, sometimes they won't. Excuse me. Let's get started now with when do we use these formula in analytics. So the distance formula, we use it, number one, to calculate the length of a line. Now this is very important, boys and girls. What I'm giving you now is a summary, because once we know this, we're then going to take all these examples and I'm going to give you one complex example question, and we're going to ask you a host of questions based on this knowledge. So if you know this, you'll be able to understand that complex situation that we are about to do in our next segment. So here we go. The distance formula, the length of we use it to calculate the length of a line or the distance of a line. Number two, we also use it for proving shapes. Now, how do you use the distance formula to prove a shape? You can prove a square. How do you prove a square? You can, obviously we know that in a square all four sides are equal. So we will then use the distance formula for calculating the length of the line. If all four sides are equal, it must be a square. If a pair of opposite sides are equal, it must be a rectangle. If you need to prove an isosceles triangle, you'll prove two sides of a triangle to be equal in length. If you need to prove an equilateral triangle, all three sides must be equal. If you need to prove a scalene triangle, obviously all three sides will be different. You can also use it for proving Pythagoras, and we all know the theorem of Pythagoras. The square on the hypotenuse, the length of the square on the hypotenuse is equal to the sum of the lengths of the squares of the other two sides. Gradient formula. We also use it, number one, we use it for calculating the gradient of a line or the slope. Number two, why would we need the gradient of the line? Obviously to get the equation of a straight line. So we're going to be using the gradient to find the equation of a line. We're also going to be using the gradient for calculating the angle of inclination. Grade 11 and 12, very, very, very crucial concept, the angle of inclination. And we all know what is your formula for calculating the angle of inclination. We know tan theta. Tan theta is equal to the gradient of the line. Okay, and we also use it, scenario number 4, to prove shapes. How would you use the gradient formula in order to prove shapes, boys and girls? What do we know? We know that for parallel lines, if we need to prove a parallelogram, a palm, how do we prove a parallelogram? Opposite sides are parallel. How will you use the gradient of a line to prove it to be a parallelogram? We know for parallel lines, the m of line 1 must equal to the m of line 2. The gradient of the one line must equal to the gradient of the other line, because their slopes must be exact. That's parallel lines. The minute the one line slope changes, these two lines are no longer parallel. So in order for them to have for the two lines to be parallel, their gradients must be equal. We also use it for proving perpendicular 90-degree lines. And if you need to prove that two lines are 90 degrees, that two lines meet at 90 degrees, how do we use the gradient to prove that? The gradient of the one line multiplied by the gradient of the other line must equal to -1. So what do we have? We have the m of line 1 multiplied by the m of line 2 is equal to -1. These are formula, boys and girls. These are formula. Please make sure that you remember them. These are the cases in which you're going to be using the gradient in order to solve. Right. The midpoint formula, obviously we're going to be using it for the midpoint, to calculate the midpoint of a line. And whenever they use the word bisector, when a line is a bisector, it means it goes to the midpoint of a line in order to break the two lines up into two equal parts. Okay, and then obviously the equation of a line, which we all know is given by y is equal to mx plus c. So boys and girls, here we go. That's your overview. This is your toolbox. That's your toolkit. We're now going to take all these tools and we're going to apply it into a given situation that's going to be worth about 20 to 30 marks. You remember, analytical geometry, grade 11s and 12s, appears in paper 2. Now, it used to be analytics first. Now they've changed it. They put data handling or statistics as question 1 in paper 2. But as a topic this year is worth 20 to 30 marks. It's marks for free. If you know what you are doing, you will get full marks in this topic. Okay, so boys and girls, let's now go on to a worked example and let's apply these models into that example. Obviously we're going to be using different we're going to be using more advanced questions in later episodes, so please make sure that these episodes on process and structure you master. Okay, so let's get started. So